Here we have two formulae used for binomial expansion that looks like this, and where n is a positive integer. Well, let's expand a plus b to the 4 using this formula. So the first term is a to the n, and here n is 4, plus, and we'll use this rule in a moment to work out the value of this, but for now we'll write 4 for n and then 1. And here we've got a, n is 4, 4 minus 1, and then b plus 4, 2, a to the 4 minus 2, then we've got b squared plus, and we keep going, this one will be 4, 3, a to the 4 minus 3, b to the 3, plus, and this last term we've got here will just be b to the n, because we'll have a to the 4 minus 4, which is a to the 0, which is 1. So I'm just going to write b4 here. And that's using this complete formula. Let's tidy this up a little bit. So a plus b to the 4 equals, this stays the same. Now using our calculator, we can work out these terms using the NCR button by using shift. So I'm going to do 4c1, which equals 4. So here I have 4a to the 3b plus, calculator again, 4 shift, get that c, 2, it's coming up as 6. So here I have 6a squared b squared plus 4c3, 4 shift, press that button again, 3, I'm getting 4. So it's going to be 4a to the 1 b cubed plus b to the 4. And if I've done it correctly, I should have one more term than the power n. So I've got 1, 2, 3, 4, 5 terms, and also the sum of the powers at each term equals n, in this case 4. So 4, 3 plus 1 is 4, 2 plus 2 is 4, and 1 plus 3 is 4, and this one is just 4. We can also use Pascal's triangle to work out these NCR or NR coefficients for each term. Pascal's triangle looks like this. Here we've got n is 1, n is 2, n is 3, and n is 4. So these numbers represent the coefficients of each term here. So we've got 1 a to the 4, we've got 4 a cubed b, 6 a squared b squared, 4 ab cubed, and 1 b to the 4. So this is 1, 4, 6, 4, 1. And again, there are 1, 2, 3, 4, 5 terms, which is 1 greater than n. This triangle can also be represented as follows. Now, each of these can be calculated to give us the same values as in Pascal's triangle. The next row of Pascal's triangle would be 1, and then 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5, and then there's a 1 at this end. And notice that it's symmetrical. This time we're going to expand 1 plus x to the 6 up to and including the term x squared. Now I like to start by doing a plus b to the 6 and then substituting in these values into this expansion, and we're only going up to x squared. So this will be a to the 6 plus, now I need those coefficients. 6 isn't too much for me to do Pascal's triangle, so I could do that quickly at the side. Now I've got 6 rows of Pascal's triangle, and it's this row that I need here. So I've got 1a to the 6, and then I've got 6a5 b1 plus 15a4 b2 plus, and so on. This term, because b corresponds to the x, will give me the x squared. Now I'm going to substitute 1 for a and x for b. And now with this expansion, I'm just going to tidy it up. And here's my answer. It has 3 terms because I only wanted to go up to x squared. If I wanted to approximate the value of 0.99 to the power of 6, I could use this expansion here by first thinking about how can I make this on the left equal to 0.99. Well, if I let x equal minus 0.01, then when I substitute it on the left hand side, I'll get 0.99. Using this substitution on the right gives me the following. Now this is only an approximation, so really we should use the approximately equals to sign. And putting this into a calculator will give me an answer of 0.94148. Or to 4 decimal places, 0.9415. This time, we know that if we start with 1 plus x and have a power of n, when we multiply it out, the coefficient of the x squared term is 55. So what is the value of n? Well, we can work this out using our formula. From the formula, this is the term that we need because it would give us an x squared. So we know that this is equal to 55, and we know that a is 1. Let's use this to work out what the value of n is. Now we know that n2 can be given using the following formula. So here we've got n factorial over 2 factorial n minus 2 factorial. And that's the value of the coefficient of x squared, because 1 to the power of anything is still 1. So this is going to equal 55. Let's see if we can simplify this. This is n multiplied by n minus 1 multiplied by n minus 2 and so on. And on the bottom we have 2 multiplied by 1 multiplied by n minus 2 multiplied by n minus 3 and so on. So anything from n minus 2 onwards can be cancelled out. So we're just left with n minus 1 all over 2. Now we can solve this one of 2 ways. Let's write it out first. n minus 1 all over 2 is 55, which gives us n minus 1 equals 110. So can you think of 2 consecutive numbers that multiply together to equal 110? Yes, we can. We can have 11 multiplied by 10 is 110. So n equals 11. The alternative method for this is to solve the quadratic by expanding the brackets. I'll do that in this space here. This gives us two solutions, but only the positive whole number can be correct.